Okay, so we are doing polygons in the coordinate plane today, and we have a couple notes, which are nothing for you to actually fill in, we're just looking at them. This first page is a review of what the distance formula, the slope formula, and the midpoint formula were. So remember, you take your 2 points, x1, y1, and x2, y2, and you subtract them, you square them, you add them together, and then you square root, which is another version of the Pythagorean theorem, right? This is the vertical change, this horizontal change, and this one is the vertical change, and then you are squaring the horizontal, you're squaring the vertical, and then you get the hypotenuse when you square root that. Okay, here are a couple of reminders of how to classify triangles, because it's been just a bit since we did triangles. If they're acute, all of their angles are less than 90. Obtuse, we have one angle greater than 90. Right, we have one angle that is equal to 90. Then scalene, all 3 different sides. Isosceles, 2 sides are the same. And equilateral, all 3 sides are the same. Okay, so classify this triangle in the figure below. So they have shown you their work. They did the distance formulas. So they figured out the distance of each of the 3 sides, and they decided that these are all different, so this is a scalene triangle. I want to show you how to do this on Desmos, so you're not having to do this distance formula every single time. So one of the links for today is the triangle grapher. You should open that up. It looks like this. Now over here on the left, do not delete any of these things. Okay, this is going to help you to find the distances. So these things with the double arrows, these are your points. And then if you scroll down, you're getting the distance between those 2 points. Alright, like this is the blue line distance from A to C. Right here is the red line distance, and so on. So let's put in the triangle from the notes. So I've got A is 1, 1. So you don't want to change it right here. You can either drag it, which is not super accurate, and then here you see I have x1 as 1.02. I'm going to change that to just be exactly 1, and my y was right. So I've got my x1, y1 is 1, 1, and then I've got 4, 2. So I want my blue point to be 4. I'll highlight it, 2 to 4. 2. Alright, so it's over there, over 4, up 2. And I want my other point to be 5, 0. So my green point is going to be 5, 0. Alright, and then you can't see that. There you go. So now you can see it over here, 5, 0. Okay, so now all my distances are done. So I have a purple line, a red line, and a blue line. Purple line right here. Purple line is 3.16 units. My red line is 2.2 units. And my blue line is 4.1 units. So all 3 are different lengths. So therefore this is a scalene triangle. Now if I move this over here and put this right on 3, 0, we should get 2 units that are the same. I'll see, it's not quite on 3. Now my purple line is 2.23, and my red line, look at there, is 2.23. So I would know that this one is isosceles because I have 2 lines that are the same. This one's just 2. Alright, so instead of you using the distance formula, that is available for you on this Desmos site. Alright, so the next one we've got classify the types of quadrilaterals. Now, these should be fresh in your mind. Parallelograms. Opposite sides are parallel because they have the same. When they're parallel, they have the same slope. And opposite sides are equal. Rectangles. Diagonals are the same length. And opposite sides are equal. And consecutive sides are going to have inverted slopes of each other. They're going to multiply to equal -1. For squares, same thing. Slopes are going to multiply to equal -1, and all the sides are going to have the same distance. Rhombus, the diagonals, here we go, negative reciprocal. That was the word I was looking for. Multiply to equal -1. And all the sides are the same length. So they did this one here, and they decided it was a square. They've got all the same distances, root 10, root 10, root 10, root 10, and they did the slopes. So let's see what happens when we do it in Desmos. You have to open up the Quadrilaterals, so that's a different link in your classroom. But it's the same kind of setup. So we got -1, 4. For A. B is 2, 5. C is 3, 2. And D is 0, 1. Okay, so you can see the quad there. And then if we scroll down, we've got our distances here. So this is our purple line distance. 3.1. This is the slope of the purple line. Okay? Then we have our red line distance, 3.16, and this is the slope of the red line. Green line distance, 3.16, and the slope of the green line. Blue line distance is 3.16, and the slope of the blue line. So yes, they're all the same. That means we know it's a rhombus because we have 4 distances that are equal. So then if you look at your slopes, here, I'm going to change that to a fraction to make it easier. Slope is 1/3 for the purple line. The red line slope is -3/1. Those are negative inverses of each other, negative reciprocals. Green line slope, 1/3. Blue line slope, -3. Negative reciprocals of each other. So that means that these are hitting at 90 degrees. So we have 4 congruent sides, 4 congruent angles, 4 perpendicular angles. So yes, this is a square. Okay. So you have an assignment, and we're just going to start working through that, and we're going to use our Desmos to do that. Okay, so come to the meet with anyone that you get stuck on. I'm not sure how far we're going to get before that, but I'll let you know. See you in a bit.